Hello, welcome back. Today we're going to take a look at arithmetic sequence, and specifically, how do you find the equation for a sequence when you're given two terms in the sequence, and then how do you use that equation to find any term that you want? Let's take a look. So today we're going to work with the question, find the 11th term of the arithmetic sequence whose fourth term is 21 and whose 15th term is 87. First, let's write down the general form for an arithmetic sequence, and that is a sub n equals a sub 1 plus d times n minus 1. Well, let's define each of those things. Let's talk about a sub 1. A sub 1 is the first term of our sequence. D is what's known as the common difference, and that means that each term in our sequence, in an arithmetic sequence, goes up by the same common difference. Now, that should sound familiar. That's a linear equation, right? So D is like slope from our linear equation. It is the constant amount between each term in the sequence. N is the number of the term. So our first term, n would be 1. Our fourth term, n would be 4. And finally, a sub n is the value of the nth term. Now, students often get confused between n and a sub n. So the way to think about it in terms of math you've done before is n is your input. That's like your x. A sub n is your output. That's like your y. So if you were going to think of a t-table, n would be your x value, your input, and a sub n would be your y value. All right, so our next step, once we have our equation on the page and we understand it all, is to fill it in for the 2 points that we've been given. So we know that the fourth term is 21, and the 15th term is 87. So we're going to put those numbers into our base equation, where again, the number of the term, 4th, 15th, that's your n, and the value of the term, 21, 87, that's your a sub n. And so there we have our two pieces of information put into that base equation. Now, you'll notice I chose to put the equation with the larger term number first. And that's because I'm heading toward doing simultaneous equations. And so I want that bigger number on top so I don't end up with negative numbers. But honestly, it doesn't matter which order. So I'm going to rewrite them by simplifying. And so here I simply did the math in here, and then I swung this number around to the front of my variable just to make life a little prettier. I now have two equations in two variables, and I can solve those simultaneously. I see that my a sub 1s both have the same coefficient, so if I choose to subtract the bottom equation from the top equation, I'm going to eliminate a variable. So I do my subtraction. 87 minus 21 is 66. A sub 1 minus a sub 1 disappears, and 4d minus 3d gives me 11d, and my final step shows me that d equals 6. Now that I have the value for one of my variables, I just go back and plug it into the equation to solve for the other. So there I'm choosing to use my smaller equation, and I stick my 6 in place of d. That's my next step. And finally, I solve to find that a sub 1 equals 3. So now that I have the value of both variables, I can write my parent equation for this sequence. So that is my equation using 3 as my a sub 1 and 6 as my d. And now I refer back to my question, which says find the 11th term. So 11 is my number of the term. So I plug that in there, and I follow my steps, plugging in 11, doing the subtraction, combining like terms to find out that the 11th term has a value of 63. Okay, run that video again, practice, Subscribe to my channel. That way you'll be alerted when I put out new videos. And as always, keep on mathing.